Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum warahmatullahi wabarakatuh. My name is Tanveer Khan. I am the student of Mechanical Engineering Department, University of Indonesia, the 4 campus. Today I am going to present my research article that is about the static stress prediction in one-dimensional bar elements using the artificial neural network coupled with the diaphragm framework. The bar is made of the S275J0L materials. So I will start from the obstrict. So obstrict is generally composed of the main statement, topic statement, objective, methodology, conclusion, and future recommendations. So the main statement is the uh, static stress prediction in one-dimensional bar element using the artificial neural network integrated with the diaphragm framework. And the objective of this study is to develop ANN model that is accurate and computational efficient. And I use the architecture of the artificial neural network in this study, which is composed of two inputs, force and cross-sectional area, one hidden layer with 8 neurons, and one output layer, which is the predicted tensile stress. And I use the log sig activation function in the hidden layer and Bayesian regularization training uh, method. Why I choose the log-seq and Bayesian regularization? Because log-seq is I choose these two based on the trial and error method. These two give me the good accurate result as compared to the other activation functions and training method of the AAN model. The result of ANN model is closely related to the FEM outcomes. Yeah, one thing, I train the ANN model through the data obtained from the FEM, and I feed those outcomes to the ANN model to train and predict the results. So the regression analysis shows the ANN model R value, which is the 0.9998, so which is like 99% uh, explain the variations in the data. So which represent the robustness of the model, and we can apply that model in in other scenarios, like we can apply to the other bar cross-sectional areas, like if they have different cross-sectional area and length, so that can be accurately predicted by using this model. So the future work of this study is to we can apply this study to the multi-dimensional stress analysis as well as the complex geometry like artificial network. We can use to the multi-dimensional stress analysis as well as the complex structural geometries. And the keywords are static stress prediction, artificial neural network, deep awareness of high one-dimensional bar element, finite element method, tensile stress analysis, computational efficiency. These are the keywords of the study. Other declarations. Other declarations of two component. One is the deep awareness of I and intention of the project. So deep awareness of I. Deep awareness of I means like who is our creator? Who created us? So we should be connected with him closely. Like our mind should be connected with our heart. And our heart should be connected with Allah. So we can uh, analyze the problems very well if if we following deep awareness of I, who made us, who created us. So by doing so, it will connect our self awarenesses and perform actions So it increase our knowledge. It can enrich our knowledge, and technical goals as well as in the spirituals. And this study, like the development of artificial neural model and integration of diaphragm framework, reflects a conscious pursuit of knowledge and truth, and grounding in the remembrance of Creator. So the study becomes an act of alignment between the intellectual exploration and spiritual understanding, ensuring that innovation is guided by ethical reflection and recognition of divine purpose. So, like, we should be connected with God. If we are working on our problem, who created us, we should be conscious. We should be thinking like conscious. So, by doing so, it will improve our skills, knowledge, whether it is related to the technical or not technical. So, this is about the deep awareness of intention. So, what is the intention of this study? The intention of this study, uh, in the context of technical, like we will predict the static stress in a war-bound element using artificial network integrated with the DiFi framework. So this is our intention that will reduce the time as well as increase the accuracies of the calculations. Or like if we predict the tensile stress in a bar, so it will the result will be close related to the real, and it will it will get less time to predict the result by the artificial neural network. So, and that will ultimately reduce the energy as well as time of. This is the technical perspective of this study. This is technical intention. When it comes to non-technical intentions, so the outcome of this study will benefit not only the professional engineers that will they use later on in their work, but also the local communities. We can use the outcome of this study by local community as well. So how local community will benefit? So when they buy something from the market, so uh, if they design manufacturing or design based on the uh, this study, that will be durable, that will be take time and will require less maintenance and replacement. So ultimately that will benefit the local people from injuries and money. They will not pay any money to replace or maintain the structure. So this is all about the non-aspect of the study intention. Oh, then introductions. Introduction, I explain a little bit about the DIFI framework. What the DIFI framework as the composition of five. The first one represent the initiator, whose name is Dr. Ahmad Indra, which is uh, the remaining four are intentions, which I explain here, and the first two I explained here. Like one is the a deep awareness of high um, intention, and the third one is initial thinking about the problem. So our problem, we will talk about the components of the problem. So I will start from the first component. So the first component is like stress analysis. We don't know about the stress analysis, how how we can conduct the stress analysis, what are the different type of stress analysis. So I discuss here in this paragraph. So we are different varieties of like we can perform the stress analysis in different way. One is the 1D element analysis, 2D element analysis, 3D element analysis. 1D element analysis, the simpler and computational less intensive compared to the other two methods. These the particular they are particularly useful for the structure that can be approximated as beam like, such as vehicle frame or I-beam. Also, simplified 1D models such as 1D bar and 1D beams are used for stress analysis and boundary chains. These models assume a linear elastic adhesive material and can simulate the entire bounded overlap using four noded macro elements. So this paragraph is explain the details of the stresses. So this is paragraph explain everything about the uh, stresses. So this is the first component of the problem, because before we don't know about stresses, what are the different type of stresses, how uh, that will explain each and everything in this paragraph. Different type of stresses, how we can conduct the stresses, so everything is explained in this paragraph. The second component is the bar. So I choose the bar in my study. So that will explain in this paragraph each and everything about the bar. Like bar is commonly referred to as cylindrical or round bar, is a long solid cylindrical piece of metal or alloy used in various industrial applications. These bars are integral in numerous sectors due to their mechanical property and versatility. Round bar are used in manufacturing of various components due to their strength, durability. Round bar are essential in producing machine parts, mechanical equipment, and seamless pipes of the oil and gas industries. Okay, I explain the, in this paragraph what is round bar, their application, their material properties, each and everything in detail, and also the material from which the round bar is made up. Like I explained here, various alloys such as the 30 uh like this here, they are made of from various materials such as the steel, like steel, so steel, aluminum, and alloys. So steel is known for excellent corrosion, resilience, and strength. Steel round bar are widely used in construction and mechanical engineering. Aluminum bar, so I mentioned here like steel, this bar is made of steel, aluminum, and alloy, and etc. So then a little bit about the steel, a little bit about the aluminum, how we use this one. I use steel, why use aluminum, why use the alloys. So I explain like here alloys, various alloys we can also use in the bar, such as the 32 CrB4 steel and AA2219 are used for a specific application require high strength specific mechanical properties. The mechanical properties of round bars such as yield strength, tensile strength, and hardness vary depend on the material manufacturing process. For instance, A2219 Li bar exhibit yield strength of 2882 304 megapascal and tensile strength of 410428 megapascal after T6 tempered heat treatment. Shape memory alloys round bar are designed to replace conventional steel bar in structural application of property elasticity and shape memory effects. Moreover, the strength of the round bar is affected by its diameter. That's why I choose the diameter, and based on diameter I calculated this cross-sectional area. So based on the cross-sectional area uh, and based on the length of the bar, I calculated the periodic stress. I calculated the stresses. So the larger diameter generally showing different mechanical properties compared to smaller ones. For each larger diameter may exhibit higher tensile stress due to the increased volume of material resisting deformations. So this paragraph explains each and everything about the 1D round bar. The third component of the problem is materials. There are various types of material we can use in a bar. Specifically, I aiming to target S275J0 mild steel. These are the type of mild steel we can use in application where the the temperature is too much low, and also uh, it's just corrosion resistance. Each and everything explained in this paragraph. So the type of steel which is widely used in construction, maintenance, machinery, and manufacturing industry due to its favorable mechanical properties and weldability. Eh, like this steel is used in marine and as well as bridges, like where there are bridges where we can handle a significant load such as beside that the J0 designation indicates that the steel has been tested for impact resistance at 0 centigrade, ensuring its performance in moderately cold temperature. It's good while reliability makes it excellent choice for the welded beams, columns, and various uh, structure application as well. Relatively expensive compared to higher grade steel, making it cost efficient choose for many construction projects. This is all about the material that I choose for the problem to study. The, the fourth one is artificial neural network. So I explain each and everything about the artificial neural network, how their literature review, who use the artificial neural network. So I explain each and everything here. And prediction, the fifth one is prediction. As we know that there are variety of methods are available to predict the results, but out of them, like the first one, static static firstly the statistical method, which include linear regression used to predict values based on relation between independent and independent variable. Logistic regression commonly used for the binary classification. New Bayes are probabilistic classifier based on Bayes theorem, and decision trees, a model that split the data into branches to make predictions. Secondly, the machine learning algorithm. So there are two main types of prediction method. The first one is statistical method. The second was machine learning method. So I will use the machine learning method, but it's because of the um, flexibility and accuracy. So in machine learning method, like we have the support vector machine, effective for the classification, aggregation task, artificial neural network used for the complex pattern recognition and prediction task, and k nearest neighbor as a simple instant-based learning algorithm. Lastly, deep learning method comprises, there are three different types. One is the first one is statistical method, the second one is the machine learning method, the last one is the deep learning method. Comprises of multi-layer perception, a type of neural network used for time series prediction and other tasks, and deep learning method employed for the handling large dataset and complex prediction tasks. And the context of stress prediction, FEA, is widely used to predict the static stress by simulation stress strain purposes of material under various loading conditions. This method can be enhanced by data-driven model to improve accuracy. So now artificial neural can be trained using the displacement and force data to predict the stresses of material. This method leverages synthetic data from vulture experiment and hence to prediction accuracy. So artificial network, I will train the in this study I will train the artificial neural network because I will configure artificial network as simple possible to predict the result. How to like almost accurate, like to I will it will be near to idealization, ideal solution. Okay, so the problem statement. So problem statement is like the prediction of structured elements such as one-dimensional bar elements remains a computational intensive task when relying on traditional finite element. While finite element offer precise stress distribution analysis, its high computational cost and time requirement for significant repetitions. So like there are already method we have for the static stress prediction like finite element method. So finite element method, the one disadvantage of the finite element method is that one, like it can take time to calculate the static stress in a member or structure member. So it require maybe the if we are using ANSYS software, so it will require more time and the resource like ANSYS software license as well. So it is too much cost. Uh, like it will require too much cost. Also the time as well. It will require because it takes time to calculate the static stress as well. So the alternative method is artificial neural network. So we will develop we will develop artificial neural network that is effective and accurate as well. So that is about the uh, problem statement, and also I will use the type 5 framework that will approach a step-by-step approach to the solution. This is a modern approach to solve the problem. Methodology. So in methodology, I explained the initial thinking about the problem, like explain each and everything about the problem components. Now I will explain about the idealization. So idealization to make the problem simpler. So I choose the materials, like there are various types of material available that we can use, but I choose the S275J0 to make the problem simpler. So because it will require then the material properties like and modulus, Poisson ratios for the training. So it will maybe require more times to train the model. So that's why I choose the material only the S275J0. So that will make the problems or model simpler. And some of the material the material mechanical properties of the S275J0 element are here in this table. The second one is finite element method. So there are various types of finite element available. Why here included finite element? Because we don't have other sources to generate data to train the artificial neural network. So for this purpose I include the finite element method to predict the stress, and then I will use those stresses, use those outcomes, those data to feed the artificial neural network to predict the stress in the bar. So there are various types of finite element available, like uh, so there are various types of finite element. One is 1D, 2D, 3D. So I will choose the 1D. 1D is simpler, that's why it will take less time to calculate the static stress. In the some of the equation I used finite for the finite element method using MATLAB algorithm. So I use these equations, like for the stiffness matrix I use the equations that depends on area, element, and the length of the bar. This is the element length, which is length of the whole bar over number of elements we divide. This is the strain, which is the change in length divided by for original length of the element. And this is the stress strain relationship. So this is about the stress and strain relationship. So up to now I will limit my video. In the next video we will start from the artificial neural network. Okay, so bye for now.